What are complementary angles? Two angles are said to be complementary when their sum add up to 90 degrees. Given a right angle triangle A, B, and C, we have a right angle at point B. We also have another angle which is 30 degrees at point A and a side 5 centimeters. On the basis of this information, we could actually work out everything in this right angle triangle. A Pythagoras theorem, before we can know the hypotenuse, we have to know both the opposite and the adjacent. If we want to know the adjacent, we have to know the hypotenuse and the opposite, and so on. But with trigonometry, we don't need that much information. To find side AB, which is the adjacent, we use the acronym SOHCAHTOA. The angle we are considering when looking for the adjacent is angle 30 degrees. Now, applying this acronym SOHCAHTOA, I want us to note that if we are looking for the adjacent, that is the A, we cannot use the SO because there is no adjacent in this acronym. Okay, we cannot use opposite over hypotenuse because there is no adjacent in this acronym. Let's move to CAH. CAH simply means cos 30 degrees equal to adjacent over hypotenuse. Now, despite the fact that there is adjacent involved in the CAH, we are not still going to use it because hypotenuse was not given. We must use the one that at least two parameters are given. Cos theta, which is cos 30 degrees, is given. Adjacent is not given. Hypotenuse is not given. Therefore, we are not going to use CAH. The last one we are going to consider is the TOA. Now, TOA simply means tan theta equal to opposite over adjacent. Now, our opposite is given to be 5 centimeters. Our adjacent is what we are looking for. Automatically, we are going to use the TOA. Now, how are we going to solve for the adjacent, which is AB? So, like we know, tan theta is equal to opposite over adjacent. And our opposite is 5 centimeters. Our adjacent is what we are looking for, which is AB. Now, how do we solve this? We are going to apply tan theta, which is equal to opposite over adjacent. Now, if we are having tan theta equal to opposite over adjacent, our opposite is 5, our adjacent is AB. So we are having tan theta is equal to 5 over AB. So by cross multiplying, we have tan 30 degrees times AB is equal to 5. Remember, we are looking for AB, so what we are going to do is to make AB the subject of formula by dividing both sides by tan 30 degrees. So if we divide both sides by tan 30 degrees, we have AB times tan 30 degrees all over tan 30 degrees equal to 5 over tan 30 degrees. So if you type in 5 over tan 30 degrees in your calculator, the answer you are going to get will be AB equal to 8.7 centimeters in 1 decimal place. So to find our hypotenuse, we could use Pythagoras theorem because two sides has been found. but I want us to use trigonometry all through. So using trigonometry, how do we find our hypotenuse? Remember, our AC is the hypotenuse. Now, to solve for AC, we are going to use sine theta equal to opposite over hypotenuse. We are going to use sine theta equal to opposite over hypotenuse, and our opposite is 5 centimeters, while our hypotenuse is AC, which we are looking for. Using our SO, which is sine theta equal to opposite over hypotenuse, we know that our opposite is 5 centimeters, while our hypotenuse is the AC, which we are looking for. Now, what are we going to do? It becomes sine 30 degrees equal to 5 over AC. So we can cross multiply. It becomes sine 30 degrees times AC, which is equal to 5. Now, having sine 30 degrees times AC equal to 5, the next thing we are going to do will be to make AC the subject of formula. Making AC the subject of formula simply means allowing AC to stand alone. Now, in doing this, we are going to divide both sides by sine 30 degrees. So by the time we divide both sides by sine 30 degrees, we are having 5 over sine 30 degrees, because sine 30 will cancel out sine 30. So our AC will be equal to 10 centimeters. We have known all the 3 sides in the triangle, but we almost know all the 3 angles except one. We know this angle to be angle 30 degrees. We know this angle to be angle 90 degrees, but we don't know this angle. This angle is missing. Now we can say that angle ACB or angle BCA is missing. How are we going to find the missing angle? That will be our focus for this lesson. To solve for theta, we know that angles in a triangle is always equal to 180 degrees. So to find theta, we are going to add everything in the right angle triangle. That's all the angles. So it becomes 30 degrees plus 90 degrees plus theta is equal to 180 degrees. And the reason is because the sum of angles in a triangle is always equal to 180 degrees. So 30 degrees plus 90 degrees will give us 120 degrees. So we have 120 degrees plus theta is equal to 180 degrees. The next thing we do is to collect our like terms. Our theta is equal to 180 degrees minus 120 degrees. And the answer for theta is 60 degrees. In complementary angles, 2 angles can change because one of the angles is equal to 90 degrees already. Now look at these 2 angles. Angle A is 30 degrees. Angle C is 60 degrees. These 2 angles can change. If this angle is 50 degrees, automatically this angle will be what? 40 degrees. So these 2 angles are said to be complementary. So I can write complementary by the side. So the 2 angles, that's angle A and angle C, can be said to be complementary angles, because by the time I add up these 2 angles, it must give me 90 degrees. Since angles in a triangle is equal to 180 degrees, I already have a right angle triangle here which is 90 degrees. Therefore, these two angles must add up to give me the extra 90 degrees that will make up 180. So angle A and angle C, they are said to be complementary angles. If angle A is increasing, definitely angle C will decrease. If angle C is increasing, that means angle A will decrease. So these two angles are said to be complementing each other. Looking at this diagram at the left here, we notice that when we are looking looking at this diagram at the left here, we notice that when we are looking at this angle from the top, our sine 30 degrees will be equal to opposite over hypotenuse, which is 5 over AC. But if I change the location from point A to point C, we are still going to get 5 over AC. But what happens here? The angle will change from 30 degrees to cos 60 degrees. So if we are having cos 60 degrees, it will still become adjacent over hypotenuse, but the location differs. This shows us that there's a relationship between sine and cosine, and that relationship is what we call complementary angles. Therefore, sine 30 degrees is equal to cos 60 degrees, which is equal to half or 0.5. You can use your calculator to check this relationship. Sine 30 is always equal to cos 60. Why? Because they are complementary angles. You can decide to change cos 60 degrees to have cos 50 degrees. So if this is changing, automatically this will do what? Will increase. That's sine 40 degrees. So sine 40 degrees is the same as cos 50 degrees. You can check with your calculator. These two, they are the same, which is equal to 0.64 to 2 decimal places. So if I decide to reduce this will automatically increase. So if this, instead of 60 degrees, we are having 50 degrees. So this now will become 90 minus 50, which is 40. So if you check, sine 40 must be the same as cos 50 degrees, which is 0.64 degrees. So if we have complementary angles, we find out that the sine of one is the same as the cosine of the other. The complement of 30 degrees is 90 minus 30 degrees. The complement of 40 degrees is 90 minus 40 degrees, and so on. So we can say sine theta is equal to cos 90 degrees minus theta. Let's look at some relevant examples. Question 1, sine 47 degrees equal to cos x degrees. We are asked to find x. Now we have to note that since cosine means the complement of sine, so we are going to have sine 47 degrees equal to cos x degrees. Now, since cosine is the complement of sine, and we know that to find the complement of sine 47 degrees, we are going to subtract 47 from 90. So what we are going to have will be cos 90 minus 47 degrees, which is equal to cos 43 degrees. So our x is equal to 43 degrees. Now, if you use your calculator to check sine 47 degrees, you will get the same value with cos 43 degrees. So sine 47 degrees and cos 43 degrees, they are complements of each other. Sine theta equal to cos 35 degrees. That means we are asked to find theta. We know that sine theta is equal to cos 90 degrees minus theta. Now, anywhere we see sine theta, we are going to replace sine theta with cos 90 minus theta. So here is sine theta. We are going to replace sine theta with cos 90 minus theta. So we are having cos 90 minus theta equals to cos 35 degrees. Now, this is the same as 90 degrees minus theta equal to 35 degrees. Now, to find theta, we collect like terms. So our theta will be 90 minus 35 degrees, which is equal to 55 degrees. So you can check sine 55 degrees is equal to cos 35 degrees.